Hi all, good morning, good evening. Let's give 5 minutes for everyone to join and then we can get started. Let's give 3 more minutes for everybody to join, please, and then we can start in 3 minutes. Okay, hi all. So let's get started. Let me start sharing my screen. Okay, so like always, whoever is new for the group call, I'll just give you an overview how does the group call goes. So I'll be explaining the system design part two. We have done system design part one in last call. Today we'll be doing the part two. And if you have any questions, please keep on typing in chat while we are doing the session. We have another SME called Azmat. He will keep on answering to your questions. Along with that, if you have any questions during the sessions, you can call me and you can ask for the questions as well. And last 15 minutes are again open for all the questions for whatever you have. So I'll give an overview of last class, what we had in group call. That is, we started system design principle where we understood the CAP theorem. We understood what is CAP theorem used for. We understood one real world example of system design. What are the problems and what are the solutions we can give through system design. We also understood how modularity, encapsulation, abstraction is useful during system design. And at the end, I told you that I will show you guys two architectures which might cover 75% of the requirement of data engineering pipelines, right? So, and yeah, I had shared this document in the school classroom. And if anyone has missed last call, they can just go to school classroom and watch the video and they can read this document as well. Now, moving ahead, so yeah, we discussed this architecture as well. There were debates on which can be the best architecture. So maybe we can replace Lambda with glue scheduler. There was no need of Lambda, so all those discussions and debates were done. Now coming to the main part where I'm showing you an architecture which can almost cover 75% of his system design interview questions, right? So just a second. Is my screen visible by the way? I hope it's visible.
Yes.
And
Yes, Naina.
let me just zoom in into the architecture. Yeah. Okay. I hope this architecture is visible. Okay. So let's first understand how system design interview can start with, right? Now I know this is a type of a complex architecture, but keep one thing in mind. You don't need to give example of this whole architecture. This architecture is going to cover 75% of your requirement, as in either you can use the upper part or the below part, or you can just use the left side, right side. So includes everything from extraction, loading to transformation. Okay, this is an ELT architecture. That is what is mostly preferred these days in data engineering. Okay. Now let's see what kind of requirements we can get. Apart from migration projects, I'm just talking about development projects. So let's start with RDBMS sources, okay? And let me take an example of anyone e-commerce website, or if they have offline stores, they might be storing their transactional data in some OLTP database called Oracle or SQL Server or Postgres, right? Now, on top of that OLTP database, there is a business requirement who needs to run some models or needs to create some reports on top of that sales transactional data. Okay. Now, we cannot directly use OLTP, Oracle, or Postgres to create reports or to create analytical modeling or to create analytical insights on top of it. For that, we first need to move the data from OLTP to OLAP system. That is analytical databases. So here I'm going to take an example of analytical databases, Snowflake. Snowflake is going to be the data warehouse in this example. Okay. Most of the data engineering requirements are you move your data from source to target. Now, when you're moving the data from source to target, you have some fixed, I would say, properties or fixed characteristics that you need to think of. Okay. Now, before going to characteristics, you first need to know how to move the data from source to target. And that is what I'm going to show you here. Now, our first requirement is if your source is RDBMS. RDBMS as in any database. Database like Oracle, Postgres, MySQL, SQL Server, all those kinds of databases. If that is your source, okay, and your target is any data warehouse like Snowflake, Databricks, or Redshift. Let's say Snowflake or Redshift for now. Okay, you need to move the data from that RDBMS source to Redshift. So an interviewer has asked you to create a pipeline to build this whole ELT flow or ETL flow. Okay. Now the very first part is how do you extract the data from the RDBMS? So there is a concept of AWS data migration service. That is what we call AWS DMS, an advanced technology which has replaced Glue for most of the ingestion part. What AWS DMS is going to do, it can directly connect. So you just need to give source connection and target connection. Okay, let's only talk about source connection. Here you're going to give the source connection as any database like Postgres, SQL Server, RDS, all type of OLTP databases, right? This is only applicable for databases or RDBMS. So as soon as an interview tells you that you need to ingest the data from RDBMS, you can think of using AWS DMS service. So I'll give you more content on how DMS works. We do have some projects on DMS as well, so you will get a practical as well. DMS will have source and target endpoint. Okay. When you give a source endpoint connection details, that is JDBC username, password, all those kinds of things, DMS is automatically going to connect to your source database and going to write your data to AWS Kinesis. Now I have considered my target as AWS Kinesis. It is not compulsory that I can always write to Kinesis. Now DMS can write to S3 as well. It can directly write to Redshift as well, but it cannot write directly to Snowflake. Okay. Now let's consider if our data warehouse was Redshift, I still had an option to directly write it to Redshift, right? But I won't do that. Why? Because we need to cut those architectures in multiple phases. Like what happens is AWS DMS is a real-time service. Okay. If let's say there is an error while ingesting data, if I consider that I am not writing Kinesis and I'm writing directly to Redshift, what is going to happen here? If AWS DMS has some issues, it is completely going to cut down writing the data to Redshift, and my Redshift is going to be down in the real-time processing, right? So in system design, you never try to, get the data and directly write it to your data warehouse. Try to build a landing area between your data warehouse and your source ingestion process. That is where I have AWS S3. Okay. Before writing it to my Snowflake, or let's say if it is Redshift, anything, I'm keeping a temporary layer of AWS S3. It's a good practice. Okay, so that you don't lose data while moving, because what happens is if you're writing from DMS to Redshift, and if something fails, okay, or if you want to validate something for that particular load, you won't be able to see the data because it's directly writing from DMS to our data warehouse, right? That is the reason we are having a temporary layer over here. Now, you might be asking before this, why do I have Kinesis and Firehose over here, right? AWS DMS can directly write to S3 as well. The reason being using Kinesis Firehose has 2 to 3 reasons. Okay. Now, DMS works in a real-time processing. It accesses the transactional logs of a source database or an RDBMS database. And if you insert a new row in your source database, it is going to understand that there is new row into database and going to write it to S3. Now, think of it as, think of every 5 minutes, your source database is receiving some transactions, right? Let's say 2 to 4 transactions. When you have 2 to 4 transactions every 5 minutes, AWS DMS is going to get that data and it is going to write to S3. So think every 5 minutes you'll receive one new file. So your AWS S3 is going to have millions of files after 6 months or 1 year, right? Now that is not very operational friendly. That is the reason what I'm telling Kinesis Firehose is, even if you receive 1 to 2 records every 5 minutes, You wait until you receive the records that are worth 10 MB. As in, Kinesis Firehose can wait and keep on accumulating all the records into itself until they receive, let's say, 100 records that are worth 10 MB. Once it's 10 MB, you write it to S3. There's an option in Kinesis Firehose. So you get the flexibility on amount or the size of the file you want to write to S3. This is the first reason. How does size affect in operations of data warehouse? Let's try to understand. So when you're moving your data from AWS S3 to Snowflake, okay, you're writing a copy command, let's say dbt, snowpipe, anything you're going to learn, you're going to move your data into Snowflake. Now what happens there is, let's say I have 5 records in one file that is worth 2 KB or 5 KB, okay? You're going to copy the file. A warehouse or a virtual instance is going to be triggered in Snowflake and it's going to write a data to your raw. Now, what happens is 5 KB of file can be written within 5 seconds, let's say. Okay. If it's written into 5 seconds in Snowflake, but Snowflake is going to charge you for 60 seconds. And that is the reason what we do is we try to accumulate as much as files that can be written into 50 seconds to 60 seconds. So let's say if I had 1 GB worth of file, okay, and I wrote it at one shot within 1 minute, I would be charged $2. Okay. But if that file would have been splitted into 100 different files, okay, and if I would have run this into real time, I would have been charged actually $100 to $200 because for every file you're going to trigger a copy command, and that is going to start a warehouse into Snowflake, and it is going to charge you for 60 seconds. So, as per the operational efficiency, cost efficiency, my Firehose is helping me here. The very last reason of using my Kinesis Firehose would be, let's say this is data engineering requirement, but let's say there is another data engineering team. Let's say you are working for a very big organization where you have multiple data engineering teams, right? Some other data engineering team wants same data, but they are not in your Snowflake. They might be using some other database, okay? What they can do is they don't have to go back to source. They can just create one more destination from Firehose over here. So what happens is Kinesis, DMS, everything remains same. After this, you will have one more Firehose over here that is going to write to another S3 location. So you can write to multiple locations using Kinesis Firehose. So what happens is if any other data engineering team, data visualization team, or Grafana or anything, anyone wants that data, they won't have to go back to source. They can directly take it from Kinesis only. These are the reasons why I have these two components over here. Now, there can be a debate that if there is no requirement in downstream, there are no huge teams, and you're fine with the cost, you're doing batch processing, I would suggest you to remove this. I would suggest you take the data from DMS and directly write it into S3. If it is a batch processing, keep that thing in mind. If it is a batch processing as in, if you're going to run your ELT load once in 24 hours, it's better to remove Kinesis Firehose and directly write it into S3. Because even if you're writing once in 24 hours, all those files which are going to go into S3, those are going to be written into Snowflake in one shot. So that's the reason maybe you can remove Kinesis Firehose. So what is the retention time frame of Firehose? Murli's question. Good question. So there is no retention period actually, Murli. What happens is you can keep the data from 0 minutes to 10 minutes. Okay. Or you can keep the data from, let's say, 1 MB to 1 GB. You have two conditions. If the files which are accumulating into the Firehose, if they are of 1 GB or 10 minutes has been passed and you haven't got 1 GB worth of data, it's going to be returned. So that's the retention period.
Yeah, the question is, let's say, for example, we build this kind of a pipeline, right? Mm-hmm. And so we were running this pipeline, so let's say for about a month or 2 months, right? Mm-hmm. And for the first 2 months, we have all the data in, in S3, and then it's going to Snowflake and everything, right? After, let's say 2 months, and another team comes in, hey, and I want to get the access to the same data, but, going with your example, they don't have access to Snowflake. If they want to get that historical data, is that historical data they have to go through Firehose, or that's what my question is. Or we'll send them to an S3 and then say that, hey, all the historical data is in S3. Go from there. For any data coming in, if you are looking at, go to the Firehose. How do you design it? Because people will get onboarded at different times, right? They may want to, let's say, for a data science team, they may want to look at all the historical data. So that's the question. So do we keep it any retention, like in the Firehose, it will stay, all the transactions, they will stay forever, or once they move to S3, and do we clean up, or any of that sort? That's the question.
Got it. Great question. So there is no retention, or you cannot get historical data through this pipeline. You will get only incremental data. Okay. Now there are two options. If you want historical data, either you take it from AWS S3 if you haven't purged it. Okay. Or second option is, maybe just for time being, what you can do is AWS DMS has a way. I mean, so you can pass on some keywords, or AWS DMS accepts some inputs, full load, CDC enabled kind of thing. Okay.
Yep.
If you change the setting of AWS DMS to full load and re-trigger it once again, it is going to take everything from source and it is going to write to your target destination.
Okay.
I wouldn't suggest that, because it is going to write to both the targets set. Like this Firehose and the another Firehose as well.
Yeah.
Yep. So maybe another, I mean, the best solution would be first is take from AWS S3.
Okay.
Or you create one more AWS DMS that is going to run only once. That is a full load, one time full load. So what we usually do is we create two DMS instances every time we move everything to production. One we keep idle, and if we want to do full load, we use that DMS. Okay. And this running DMS is always CDC enabled. It means there's property CDC enabled. This is just going to give you incremental data. If you want to do full refresh, there is one DMS sitting idle.
Okay.
That is not real time. You need to trigger it ad hoc whenever you require it.
So that means basically, if you're looking at a different table, right? So let's say first attempt, we'll only get about 10, 15 tables, which are required for our data warehouse, right? And then after that, they say, oh, we need some more data. So that means we need to get a full load of those tables also from the DMS, right?
Yeah. So in that case, no, you won't use that full load one. You will use this one only. So how DMS works is, if you are adding new tables, okay?
Yeah.
If you're adding new tables, you have a property of full load and CDC enabled together.
Yeah. Yeah.
Okay? If you add new tables, for new tables, it's going to do full load and then CDC incremental.
Oh, yeah. Yeah, that's right. Yeah. Yeah. Okay.
Now, if you want to do full load of all the tables, then only you need to use the first method. Another AWS
Another DMS server. Okay.
Yes. That's right.
Okay.
Good question. Great question.
Hi, Ninant.
Yep, Aish. Correct.
So, I mean, before you said that you can directly write data from AWS DMS to S3, right?
Right.
You are writing the data from AWS DMS to S3, and then you are creating a layer of AWS Kinesis and Firehose so that the data can be accumulated from S3 row by row, and then at a single time, it can write the data to Snowflake, right? Am I right?
Yep.
So why Kinesis and the Firehose belongs in the middle of S3, shouldn't those parts be coming after S3?
No, like I said, see, Kinesis Firehouse is going to club the files before
Okay.
writing to S3.
Oh, okay.
Okay. So if you have a requirement of real-time processing, you go with AWS DMS, Kinesis, Firehouse, S3, Snowpipe, and Snowflake.
Okay.
Because in real time, what will happen is you'll have small batches of files, right? And that time your Snowflake warehouse is going to be triggered every 1 minute, every 5 minutes, and that's going to cost you a lot. That is where we suggest clients to add Kinesis Firehouse in between, where you club the files until it becomes like 50 MB, 100 MB, 1 GB worth of files, right? And then only write it to S3.
Okay. Mm-hmm.
Yep.
Oh, so sorry for quick question. So you only use Kinesis and Firehouse to save money. So it's about how many? So Snowflake can digest. What's the maximum Snowflake can digest? Like the memory.
Yeah. So to be very honest, we use Kinesis Firehouse very prominently if there is a real-time requirement. Okay. But I've added this here so that when you go into interviews, when you explain about Kinesis Firehouse, it looks like you have advanced knowledge of AWS. That is the first reason I've added here for you guys. But use it only if it is real-time streaming application or real-time streaming data pipelines. First part. In Snowflake is going to charge you on every minute. It doesn't charge you on how many GB worth of files you are copying. While copying, what happens is, if your warehouse is up or warehouse is active for 1 minute, it's going to charge you $2. Let's say example. Okay. So if you're moving 1 GB worth of file, 10 KB worth of file, or 1 MB worth of file. If your warehouse is active only for 10 seconds, then it's going to charge you $2. Make sense?
Okay.
And that is the reason we added.
So basically for the, sorry about that.
Good.
Linant?
Yeah, good.
So basically for the real-time processing, you have the source data at the DMS, AWS DMS. You are accumulating those using Kinesis and the Firehouse, and then so for example, you are accumulating row by row using Kinesis and Firehouse, and when you have like 50 MB or 1 gigabyte, you put it to S3, and then you are using a snow pipe or and Snowflake so that you can send all 1 gigabyte of data so that it charges for 60 seconds only instead of, right?
Yep, that's right. That's absolutely right.
So that is like a cost optimization.
Yep, that's cost optimization architecture.
Okay.
So when in interview, when they ask for your system design questions, just don't tell about no, I'll use AWS DMS Kinesis Firehouse 3. Give the reason behind it. That is what I'm telling you guys. So whatever things you're going to use, whatever technologies you're going to use, you need to know the reason behind using that specific technology. Okay. Going ahead. So let's say if you have real-time requirement, real-time data pipeline, I'll move it through SQS, Snowpipe, and in Snowflake, we will use task streams and stored procedures. Anyone who doesn't know, I've already assigned you guys the projects where you will be using Snowpipe, SQS, S3, streams, tasks, and stored procedures. So whatever you see in this real time, except DMS, I haven't assigned it to everyone. So, but yeah, we do have the project on that. Kinesis, Pyros, S3, this part, whatever you see in real time, you guys are going to do the project on that in depth. So you'll get a hands-on experience of how Snowpipe works, how you're going to move the data from Snowpipe to raw layer, staging layer, and warehousing layer. And yeah, so this is the real-time requirement where you get the data from DMS if there is any RDBMS source. So keep one thing in mind. If you get RDBMS source, you can close your eyes and say that I'm going to use AWS DMS because I don't need to schedule it. It is real time. It automatically scans the transactional logs. We'll give you the theory knowledge pretty soon. We'll send the documents and all those things, and then move it into S3. Kinesis Kairos if it is real time, and then move it into Snowflake using Snowpipe SQS. Now, these three layers, we will double click this after 2 sessions, because this itself, the design of data lake, delta lake, or data warehouse, right? That itself is a very big session. So consider this in data engineering and data warehouse or data lake, we are going to have 3 layers.
So for the transformation, you are also using like a Spark or PySpark something, or
No,
how?
this is Snowflake task and streams. So you guys will be doing that project pretty soon. Whoever is interested in data engineering, I've almost assigned this project.
How does the transformation works? Like, what are you doing after putting it into Snowpipe? How do you transform those data?
Yep. So that's what. So what we're going to do is this part, we're going to double click this after 2 sessions.
Okay.
Because I want to give everyone some time to get hands-on with this. So we
Okay.
have assigned you those projects, and once you get some hands-on, you should be able to understand it, because if I only explain you theory, it's not going to be very useful for you guys. So this part we'll be taking after 2 sessions. Only the transformation.
Avid, on the high level, the transformation, what we are doing is running a SQL query, right? Whatever transformation you do on a data warehouse or database, it's running a SQL queries, right? So that SQL query is what you're trying to run is being run through the streams and tasks, right? In your case, it could run through a Spark also, right? Or it could run through a DBT also, right? So
Okay.
technology change based on your requirement, but the underline is that you want to run a SQL query. That's all.
Sure. Okay. All right.
Yep. Now this is real-time pipeline. Let's say some of the client comes in and they say, I want batch processing. I'm not interested in real time. I'm fine with batch processing. In that case, I'm going to remove Kinesis Firos completely from the picture. Okay, I'm going to take all the files, load it into S3. Batch processing is you trigger the pipeline once in a day or twice in a day, something that kind of on a scheduled time. Okay, so you get the data, write it to S3. In this case, I'm going to use dbt cloud. Okay, dbt cloud is going to be used to write all our SQL code, transformation code. It is going to copy the data from AWS S3 to Snowflake, and again all 3 layers. Like I said, we'll be writing SQL to do all the transformations. Our DevOps pipeline will be triggered through GitHub and AWS code command and all those things, right? So our code is going to sit in GitHub. CI/CD is going to be, sorry, not code pipelines and all, my bad. If you're using dbt cloud, you don't need anything else. dbt cloud automatically supports the CI/CD. So that's why I'm using dbt cloud. And the transformations are going to happen in Snowflake only again. What are
So
these?
if we do not use the dbt cloud, then we have to, have a different mechanism, right? How do we do that? Let's say if we put all the code into Git repo or a Bitbucket, right?
Got it. So let's say instead of dbt cloud, you have dbt code, which is going to run on AWS batch. Okay.
Yeah.
Or AWS Glue. So what happens is all your code, you develop it locally, you push it to GitHub, and you create a DevOps pipeline using AWS code build, AWS ECR, and Docker image.
Okay.
Okay, now let me see if I have that handy here.
Hey, Ninant.
Yeah, go ahead.
These questions may be very silly, but I still wanted to ask.
No problem.
Some company talk about CI/CD pipeline. What do they mean about that? I have never used it in my life.
That is continuous integration and continuous deployment. What it means is, once you do some development, okay, you put your code in GitHub. Okay. Now GitHub is just data, your code repository. Okay. It's not really going to run your code on GitHub, right? So all your code is going to be triggered through dbt, correct?
Really? Okay.
Now once you push the code into GitHub, it should be replicated into DBT. That is CI/CD, continuous integration, continuous deployment. As in deploying your code from your repository to your framework. In your case, let's say if you have Spark, which is running on EMR, all your notebooks are going to sit in GitHub, and the ECR image is created using that GitHub and Docker, and that image is going to be used by Spark EMR.
So wait, you have the development already, right?
Yep.
For example, the development means it's a batch processing from the DMS. You are using Kinesis, Firehose, S3, and batch processing. You are sending it to the DBT, right? And from DBT, you are storing your notebook or your code to GitHub, right?
Yep.
And
because
how it is being triggered from GitHub to DBT.
Yep. So in DBT, in DBT Cloud, you have an option on the left. Hold on. Let me just see. Just a second. Where is the UI, DBT Cloud UI? Let me show you. Yeah, you can see my screen, right? I've opened an image.
It's very small.
Okay. So here, if you see on the left side, this is the DBT Cloud UI. This you see version control and commit and sync. Whenever you write your code, you can just click on this commit and sync, and it's going to be returned to your GitHub. And when you're running your production pipelines, you won't have this UI. Everything is going to run through GitHub. So DBT is going to pull the data or pull the code from GitHub and then going to run it in production.
So let me see if I understand it correctly. You, after everything, after S3, all of that, we got it. And then you are bringing DBT as part of your CI/CD pipeline. From DBT, you are sending your code to GitHub. And now you have to make any changes, you are doing it via DBT UI, and you are commit the changes and pushing it to the GitHub again. So that is called a CI/CD pipeline, right?
Yes, kind of. Yep. Continuous integration, continuous deployment. In this case, yes.
Okay. All right. Sure.
Yeah, so so Abid, this is one example, right, where Ninada shows that okay, DBT code is going to the GitHub. CI/CD is nothing but the migration of code to a different environment, right? So usually, previously, what we were using before the CI/CD, that okay, you make all the code in the development environment and give it to somebody who is going to take that code and migrate to the higher environment, which could be your SIT, UAT, and production, right? To avoid that manual intervention, what the CI/CD process came in picture, right? Where you write the code into Git repository, you just click of button, your code will deploy from your dev environment to your SIT environment, from SIT to UAT and UAT to production, right?
Okay.
So there the manual intervention has gone, right? So that's the CI/CD process.
Okay. All right.
Yep. Now, while okay, any questions? I'll go to this two tools later. Any questions into
Ninad, I have a question. Why are you not using DBT in real-time processing? Why only use it
okay, why are we not using DBT in real-time processing? Good question. So what happens is real-time processing, as in once you get data into S3, your DBT cloud should trigger that job, correct? There is no mechanic. So in real-time processing, how it happens is as soon as you receive data, it should move to next phase. So as soon as there is data in source database, AWS DMS is capturing it. It will go to Kinesis, Firehose S3. As soon as the data, lies into S3, it should be moved to Snowflake, right? DBT Cloud doesn't have that feature where it can understand that there is a new file in S3 automatically. In order to run it real time, DBT Cloud should understand that there is a new file in S3, right?
Okay.
We cannot do that in DBT Cloud.
Okay.
DBT Cloud needs to be triggered through a schedule or cron trigger.
Okay.
It cannot understand if there is a new file in S3. That's the reason
Oh,
we are not using DBT cloud for real time. And that's the
okay.
reason we are using SQS, Snowpipe, and Castings for real time processing.
So let's say
So
if you have infinite money, so what do you prefer for batch processing? Like we not related to any
Sorry, what do you
cost
have infinite?
optimization.
I didn't get it.
I mean, we have a surplus amount of money, and we're not thinking about any money or in terms of batch processing. So directly we push S3 to Snowflake, right? Every 1 minute or
S3
so.
to DBT to Snowflake. DBT will push to Snowflake
Okay.
because you
So
don't
it's
need
something.
Snowpipe at all if it's batch processing.
Okay.
I have a question. So
Yep.
we are adding additional tools like Kinesis and Firehose in the architecture, and when we are doing it, do we have to understand the security part as well, or the access
Yep.
rules
Great
as well?
question.
And
Yes.
also one more thing is like when we are adding this, are we also there is expecting a data loss when the data is going to pass
Yep.
through so many tools?
Yes, that's a great question. That's correct. Just before coming to the answer, so what I've done is when you guys are doing system design or designing an architecture, at least what we do is I'm just first telling you what all things needs to be considered, and then I'll come to that question. So while designing your system or while designing an architecture, split it into 6 parts. You need to decide your target database, ingestion or extraction from sources. How are you going to load it into target database? And what are the tools or technologies you're going to use for transformation? What is the scheduling mechanism? CI/CD and DevOps part. These are the main parts you need to design. Okay. Once you have designed an architecture in your mind, you need to compare those things with whatever is written here. Okay. First thing is whatever target database you're going to decide, that needs to be at least minimal terms of ACID compliant. ACID compliant, it's so I'll just give you basic idea of ACID compliant. It means atomicity, consistency, isolation, and durability. That is, whatever transactions or whatever rows we are going to write to our database, every row should be committed in a separate way. And whenever we are writing into target, that one row, it should be isolated. As in, let's say if my location is as of now New York, I'm writing into target database, and there is some another process that is updating my New York to, let's say, Texas. It shouldn't be allowed. That is what we call isolation. Guarantees all the transactions will occur in isolation. Okay. And durability is once it is committed, you should be able to view it, and it should, even if system crashes, you should still be able to select and read that data. So I'll give you more theory on ACID transaction. What does it mean? But this is very important when you choose your target database. Second thing, you need to think of partitioning of data and change data capture as well. We'll come to the data partitioning in some time. We have that topic. We need to see what is the support and community for all the tools that you're using in the 6 parts. Okay. Fault tolerance. That was the question just asked. If there are any errors, how do we reload? How do we understand? That mechanism should be added in your architecture as well. How are you going to understand the data lineage? This is, I would say, optional, but if you add this in your architecture, it means you know advanced AWS or advanced data engineering topics. Okay. This is advanced one. This is also advanced one. How do you handle the data governance? How do you handle the data quality? These 1, 2, and these 4 questions. It's very common these days. Sorry, 5 questions are very common questions during a system design interviews. That is, whenever you design your system, how will you do the fault tolerance? That was the question. How do you do the failure recovery? How will you recover the data that has been failed? How are you going to maintain the data quality? How are you going to do the data lineage and all these things? After that, you need to think of alerts and monitoring. Whatever system you're going to provide, how do you provide the alerts and monitoring? Okay. So whatever scheduling mechanism you're going to use, there are multiple things you need to think in that scheduling mechanism as well. Whether it can handle the dependency or parallel runs, whether it is compatible with multiple ETL tools like DBT, Informatica, Matillion, there are n number of tools now. whether your scheduling mechanism has API access, it has error handling thing, can we appropriately log and monitor all our workflow jobs and those kinds of things, whether it is user interface friendly or developer friendly as well. And again, you'll have to think of alerts and notification and scheduling and mechanism. So if you only think of these 10 points while designing your architecture, that will cover almost 99% of your system design interview questions. Now I know these are a lot of things, but once we go ahead, I'll be showing you guys what all technologies can be used, let's say for data lineage. In my current architecture, I'm taking care of almost 7 points in this. I'm not saying I'm taking care of all the 10 points. I'm taking care of almost 7 points. I have data lineage. I have data quality checks. I don't have data governance yet there. I have fault tolerance as well. Support and community is good. Data partitioning also there. So you need to think of this. Moving ahead to
Ninad, I think you can add serialization isolation issues also. I think like last class you mentioned about it.
Yeah, that comes in your asset compliance only.
Oh,
Isolation
okay.
comes in serialization isolation.
Okay,
That's a
understood.
good point. So that comes in isolation in asset compliance. So that is the main first part. That is what you first need to check in any database. Yeah, we'll get into deeper. But to answer your question on, I think, how will you understand if there are errors, right? Okay,
Yeah,
let's come to first. Yeah, sorry, go ahead.
Yeah, so if there is a data loss, and also like these policies is practiced uniformly throughout the industry, or it depends on the domain where you're working or the product you're working. Those practices needs to be customized, like, or it should be like there are standard practices throughout the industry which we need to follow.
Yeah, so good question. So what happens in data engineering is, for a certain period of time, there are certain tools that are widely used. We cannot say it as a general practice, but what happens is, let's say AWS Glue. There was a time of 4 years from 2018 to let's say 2022, where Glue was used widely by all the companies, right? But that is not a general practice anywhere written or theoretically presented in any paper. As a data engineer or architect, you need to design the robust pipeline. Now, what happens is, if there are limited technologies available, okay, that solution itself becomes a general guide. So now what happens is, I'm not using here AWS Glue for my ingestion. Why? Because AWS has launched AWS DMS system, which is very easy to use. I don't even need to schedule it. I don't need to write manual coding, right? Now what happens is, slowly throughout, so we started using AWS DMS in 2022. Now for last 2 years, a lot of companies have started using DMS. You will see a lot of companies have started using Kinesis Firehouse as well, right? So it's not a general guideline, but it's that companies start using it because AWS suggests them based on your problem statements.
Okay.
Now, coming to your first question on securities. I think I missed that part here. Sorry for that. I need to add that as well. You need to think of security as well. That's right. So first part, when it is AWS DMS, when you're pulling the data from your source database, that is going to be AWS DMS encrypted as well as KMS encrypted. AWS is going to in inbuilt way, it's going to encrypt it, and you can add a KMS encryption as well. If there is a question that someone wants to encrypt the data, so what you can do is you can use KMS encryption on top of AWS DMS. There is option.
May I know why we need to encrypt the data?
Yeah. So see, your Oracle is in on-prem. It is not in your AWS VPC. Okay. Now, when you're pulling from out of AWS VPC, it's getting transferred from on-prem to your VPC. Someone can trace that, and someone can access that data while getting migrated from your on-prem to your VPC. That is the reason you need to encrypt it.
Is that set up in AWS DMS or the encryption in transit?
Yeah, we can do it in AWS DMS.
It's either a flag or some property or something like that.
Yeah,
right?
there's a property where you can do KMS encryption. For that, you will create an AWS KMS key, and that key you will have to add in AWS DMS KMS encryption feature.
Okay.
So it's a feature in AWS DMS. Now, once it's in your AWS VPC, now it's mostly encrypted with KMS, right? But still, what we suggest is throughout your pipeline up to AWS S3, you keep it encrypted only. That is the most secure way. That is, when you move from DMS to Kinesis Firehose, we still keep that KMS encryption on. Kinesis Firehose also has the KMS encryption. In S3 as well, you can do KMS encryption. So the general practice, this is the general practice, is you encrypt the data into production while you are ingesting it in VPC, and even after it is ingested in your VPC, even when it's in S3, no one else can access it, even if your S3 gets hacked by mistake. That is why you have KMS encryption on top of your S3 bucket as well. So the general practice or good practice is you encrypt each and every AWS technology that you're using for this data pipeline. I hope that answers your security questions, right?
Yes. Yeah.
Now moving to error pipelines, right?
So
initially when we started
Real
using this
quick.
technology,
you're encrypting Kinesis and Firehose?
yes, Firehose Kinesis
Okay.
as well.
Okay.
Yep. And you know what? If someone wants to access this data, they need to get the access to that KMS key. Then only someone can access this data through S3 or Firehose. Or else it's going to give you access denied. Okay, cool. Let's move it quickly. We have last 9 minutes on the error pipeline. When we started using this technology, we faced the same issue. What will happen if something failed while transitioning the data from AWS DMS or Kinesis Firehose, right? So every AWS technology has its logs. If there is any failure, it is going to be logged into AWS CloudWatch logs. What we did is in AWS CloudWatch, you can filter based on the error logs. So there was one more monitoring mechanism which we created, which used to continuously check their logs, like AWS DMS's logs, Kinesis logs, Firehose logs. If there is any error log, it used to send an event to a Lambda, and that Lambda or SNS, let's say SNS. Okay. So what used to happen is, if there was any error log, we can trigger an SNS notification event using a CloudWatch event. And that SNS used to drop in an email to us that there is a failure in so and so. And then we can come back and then manually check it. We cannot do any automations there. So the point is, you keep on checking the logs. And checking the logs can be automated. That is through CloudWatch logs and event logs. Even if that is not very helpful, I'll share you the documentation as well. I'll share you one architecture where that is implemented, so that will help you guys to picturize as well.
Yeah, that will help. And you will also discuss in deep the data partitioning, right? That's
Yes. Today I don't think so we have it. I already had it here actually. Data partitioning and scalability. That was my next topic today.
okay.
Horizontal scaling, vertical scaling, partitioning, example of partitioning, and all those things. But yeah, I don't think we can have it today. Maybe we'll discuss this architecture whole, and then only maybe we'll close it for today. But yeah, we'll be discussing in next few calls.
Thank you.
Cool. So yeah, this was if you have RDBMS source. Let's say if you have API calls, if there is a data sitting in some APIs, a simple API gateway, you guys are going to do real-time streaming, the real-time data streaming project. The rest of the architecture is same, Kinesis, Firehose, S3. If you want real-time Snowpipe, if you want batch DBT, the only thing what changes is API gateway. What happens is here, you have if someone is going to push the data, they can push through API gateway. All the security and all those things, bit changes here. Here for security purpose, we use kind of mutual authentication or token validation kinds of things. That's how the security is taken care in API gateway. But if there is an API requirement that you need to get the data from API, and you need to create a pipeline, what you do is you create a lambda before this. Okay, that lambda is going to get the data and write to API gateway. If someone is going to push it or post it, you don't need lambda. They can directly write to your API gateway. So this covers if you have a source as RDBMS or source as API gateway. This almost covers 75% of requirement. Can someone quickly give me a requirement which cannot fulfill these two things? If someone has anything on top of their mind, maybe not API.
I have a question. Let's consider an IoT device, where in IoT we use MQTT and everything, right? So can we inculcate those technologies here?
Yeah. So let me tell you, if it is an IoT device, you already have the logs or events written to AWS S3, correct?
Okay.
So you don't even need it here. Your architecture starts from directly from S3. Let's say if it's not hosted on AWS, if there is another IoT device, still IoT means you'll have an API, right?
Yes.
So either you'll have a lambda. If they can push it to your API gateway, or you can create a lambda before API gateway, get the data from that IoT device through API and write to your API gateway. And same process.
Quick question. The other use case, typically, the places where I worked is you get the third party data into their
exactly
either their SFTP folders or something like that, right? So
great question. That's what I was expecting from someone. That's why we have 75% here. I haven't mentioned 100%. So for SFTP, usually what happens is, let's say if you are using client side, let's say there is a concept called global scape. They have their own SFTP, right?
Yeah.
Now what SFTP services have enabled is you can host their SFTP service in your AWS VPC as well. First option. Okay. So if that SFTP is hosted on your AWS environment, you can directly write the file to AWS S3 through that SFTP service. So let's say there is a SFTP service called Global Scape. If Global Scape is hosted in your AWS environment, you can directly write to AWS S3. Let's say it is out of your what do we say, AWS VPC, right? AWS has a file transfer service. I think I forgot its name. I'll get you guys that name, where you can have your own FTP in AWS, and we can ask the client SFTP or FTP to send data to our FTP. Second solution. Yeah, push it to our FTP. Second solution. Third solution, you write a simple glue script to get the data from that FTP and write it directly to S3.
Okay.
That is where that rest of the 25% lies.
Okay. And one question here, right? Mostly, in the top half of that DBT, right? Typically, DBT is a transformation tool. Right? That means it's going to read from a database and then do the transformation and then push it to their target database, right? In this example, in the top half, you are saying that the DBT is going to read from S3, like like Athena query or something like that. Is that what it is doing?
No. DBT is not a compute system. DBT is just a, I would say, transformation tool where you are just going to develop your code. The computation still remains on Snowflake. Okay. So what happens here is,
how do we load it into? So my question is, how do we get the data from S3? In a file. Oh, you're running the copy command.
Using DBT.
DBT into the raw layer. Okay, got it.
Yep. And that's how we get the data. So DBT is just a tool where you write the code. No computation at all.
Okay. Perfect.
So, Linand,
Yep.
From S3 to DBT, you are writing copy command every single time, or is there any step function or anything we can use so that it automate the process from
Yeah.
S3
So copy
to
command
DBT?
is one-time activity. You write a generic copy command, because see, when the file comes from DMS, it is going to write to same S3 folder every time. folder is not going to change, right?
Okay. Yeah.
So when you're writing a copy command, you write copy command from S3 folder to Snowflake table. So it's a generic one.
So, okay, S3 is a storage. So you are taking it from S3 to Snowflake using the dbt command, right?
Using copy command that runs on Snowflake. dbt is just a tool to code. So dbt is just going to send a command to Snowflake.
Okay. All right.
Yeah. So
So
once you
just
start
like
doing
a
some
Jupyter
projects,
notebook, right?
sorry, go ahead.
DBT Cloud is synonymous to Jupyter Notebook, right? Something like a interface where you try to code.
Jupyter notebook, yes, but not in a notebook terms. I wouldn't define it in notebook terms, to be very honest.
Okay.
Do
Like a PyCharm.
we have
Yes.
a project that covers this architecture hands-on?
Yes. So I have assigned it to everyone. You guys will be doing real-time streaming project. You will be doing dbt DynamoDB project where you use dbt. You will be doing Snowflake SCD1 where you will be using SnowPy task streams. Snowflake dbt SCD2 where you will be implementing dbt cloud and SCD2 using dbt. So yes, you will be doing all hands-on. You'll be using Kinesis Firehose in real-time streaming as well. Just the DMS part is not there yet. You will be assigning it we'll be assigning you that soon. API gateway is there. All these things you will be learning in practical as well. Cool.
So if they
Great
ask
session.
about I have a question. So what if they ask about that scalability and distribution, right? Distributed data sets.
Yes.
What we should answer here?
Yep. So scalability and all, I do have that. We will have it in next session. So that's what we wanted to have, but I couldn't complete it. Distributed system is not Snowflake. It's completely on Spark and Hadoop.
Okay.
So that architecture will be completely different. But yeah, we will cover in like after next 4 to 5 sessions. Once we are done with all the theory part, I'll give you some guys example of Databricks and Spark kind of architectures as well. As of now, I'm just showing basic architecture with Snowflake so that at least you guys understand how do we design the system from source to target. That is why we're showing this. Yep, distributed is like more advanced, so that's why we haven't added it yet. We'll be adding it later.
Means I have a quick question. So Snowflake, why is it not distributed? Because it's even it have its nodes, it's built on AWS on it, so it should be distributed.
Yes.
So,
but what happens is big data distributed systems are mostly on Hadoop, and people expect Spark and Hadoop. Mostly Spark.
Okay.
So but the parallelism is automatically into Spark, right? It's not available in Snowflake. Obviously, it has multi-clustering and nodes and all. It's a distributed system only. But if you think of a typical answer in distributed system, everyone expects Spark, nothing else.
So it comes in loading phase, right?
Yep.
In place of Snowflake, it should be Hadoop distributed.
It should be in Databricks Spark. That's what I will be showing.
Okay.
Yep.
Okay. So in the previous example, in the last session, you showed the bronze layer and everything. So
yep, that will be part of that. Yes. Here also we have 3 layers. Instead of bronze, silver, gold, we have raw staging warehousing. Bronze, silver, gold is a Medallion architecture which falls under the Delta Lake. We will be covering everything. Don't worry.
Okay. Thanks.
Yep. If you need some theory knowledge on all these things, you can do the fundamentals course on our portal. That is everything like data lake, data warehouse, and all those theory part. But yeah, we will be going into practical pretty soon. So we'll go step by step. As of now, you guys understood at least what is the requirement and what we can do. Yep, I think we are over the time.
Ninan, can you share the documents?
Yes, I'll be sharing the document in school classroom. You guys can access it from there.
Okay, all right.
So thank you all. It was a great session. I hope you guys enjoyed it. Next session, we'll continue the rest of the part. Thank you all. Good day.
Thank you.
Thanks, everyone.
Thank you, Nina.
Yeah.